Okay, here's the analytical question where they say determine the equation of a line that it be parallel to AB, but it's going to pass through C. Well, if it's going to be parallel to AB, we're going to need the gradient of AB. So we go 3 minus 1 over 2 minus 4, 2 plus 4. We get 2 over 6. The gradient of AB is 1 over 3. Well, if this line's supposed to be parallel, it's got to have the same gradient. We just take this gradient and we take the C point and we put it into the point gradient formula. And there goes your minus x1, your y minus y1. 1/3 goes in for m, and that's your answer. You just have to clean it up a little bit. 1/3 times x is 1/3 x. 1/3 times minus 11 is minus 11 over 3. We're going to add 4. No, we're not. We got to subtract 4. But let's subtract 12 divided by 3, because then we'd have a common denominator. We could just do it in our calculator, I guess. But minus 11 minus 12 is minus 23 over 3. And there's the equation of the line that's parallel to AB, because it's got the same gradient, but it passes through 11 and minus 4. Okay, let's try the next question. Determine the coordinates of a point P such that DC is parallel to AB, but DA is equal to DB. Ooh, this looks like a little bit more work. Okay, a point such that DC is parallel to AB. DC is parallel to AB. Well, the point D, what we do is AB is parallel to DC. So the gradient of DC is equal to 1/3. But we've got a point D here. I guess we should have said D is the point we don't know about, X and Y. X and Y. But if we want to find the gradient of DC, we have to go, the change in Y is Y minus 4 over X. You see, here's your point D. You just don't know it's X and Y. X minus 11. Change in y, y2 minus y1 over x2 minus x1. We're just using C there. That's why it says DC. But D is the point xy. Okay, so we multiply that 1 by x minus 11. We multiply 3 times y plus 4. And then we just add 11 to that. We get x equals 3y plus 23. Well, that's our first story. Now they say dA is equal to dB. Well, D is this xy thing. We just look at A and we look at B and we use the distance formula. Let's look at dA first. So x minus 4, y minus 1. You see we're finding the distance from the variable D point xy to this fixed point A. And we do the same thing over here with B. X minus 2, y minus 3 squared. And now all you do is expand all this stuff. And hey, the nice thing about this is the x squareds go, the y squareds go. You just subtract it from both sides. If you add 4x, you're going to get 12x. If you add 6y, you're going to get 4y. If you put the numbers together, I think that's 17, and that's 13. If we subtract 17 from 13, we get minus 4. Ooh, this is nice because 4 goes into everything. So we get 3x plus y equals minus 1. Now we know that x is 3y plus 23, so this looks like a good question for rubbing out x and putting 3y plus 23. We just multiply it out here, 9y plus 69. We subtract 69. And we go 9y plus 1y is 10y. We divide by 10. We get y equals minus 7. There's half our answer. Just take minus 7 and put it back in there. 3 times minus 7 is minus 21 plus 23. X is 2. So the point, that's the end of it there. The point is 2 and minus 7. They go through. And there's question 3. All done.